taught you this derivation where its refractive index is equal to real depth by apparent depth. Yeah, all that is taking into consideration the ray is coming from denser to rarer. We have arrived with a formula. So now when numerical is there, you can directly apply the formula. Okay. Now you know that this is the real depth, which is OB, and you know this apparent depth is IB. They might ask you what is a shift. Shift means this is shift OI. And to find what is shift, let's write here what is shift. OI is equal to the real depth OB minus apparent depth IB. So what is bigger here, the real depth? Let's take the real depth out. So you write 1 minus IB by OB. From here, can you see I've circled it here? I'll circle it in red color for you guys. Can you see from here? That it's IB by OB is 1 by mu. So IB by OB is, therefore OB is equal to, OB is nothing but the depth of the water. I can write it as D or T. For now I'm writing it as T. 1 minus 1 by mu. And this is the formula for shift. Are you clear? So once you're done with this, then let's do some numericals. Okay, there's a beautiful numerical here which has been given. I'll do it again. Sorry, I have to do it fresh for you. Okay. So there is this question. I tried this question because I found it very difficult to explain. So I tried this question without recording, and now I'm going to do it with the recording. So therefore this sum is going to be very complicated for you all. This is sum number 20, where a glass beaker of height 10 centimeter, yes, I've marked 10 centimeter there, red color la, completely filled with water of refractive index 4/3, have a curved bottom which is polished, which means silvered, which means it's going to act like a mirror. A plastic coin remains submerged in water at a depth of 5 centimeter. Can you see I've drawn a plastic coin here? This is the plastic coin which is at a depth of 5 centimeter, which that is the actual depth when seen from the naked eye. Correct? Now an observer sees the coin in water, but now the observer is not looking at the coin with the naked eye for now. He is going to look at the coin. The observer sees the coin in the water and its image in the mirror. So you know if this is 5 centimeter, for the curved mirror, what will be the object distance? 10 minus 5. So u is equal to minus 5 into 10 to the power minus 2 meter. Write this as a first step. So you got your object distance with respect to the mirror. It's a concave mirror. So it's to the left of the mirror or above the mirror. Here we are taking it as negative. Next, they have given that when observed through the mirror, he is getting to see the object at 15 centimeter. He is getting to see the image at 15, whatever he sees. That will be the apparent depth. What he gets to see through the mirror is to be considered as the apparent depth as seen through the mirror by him. So you know the apparent depth, you don't know the real depth. But you know the real depth has to be larger than the apparent depth. Okay, so then therefore use refractive index formula. 4/3 is equal to real depth you don't know. Correct? Apparent depth is given as 15. 5 3s are 15. So the real depth itself became 20. So the x is equal to 20. So you know this is 20, the beaker's height is 10, therefore the balance distance here will be, I'll write it in blue color, okay, the balance distance here will be 10 only. And that has to be considered as B because you already know what is U. For the mirror, this is your V. So you know the mirror formula is 1 by F is equal to 1 by V plus 1 by U. Therefore 1 by V is 10, 1 by U is, with the negative sign, it's 1 by 5. You don't have to convert into meters in these kind of sums because focal length will be only in centimeters. Okay, unless you're going to convert into power. That's when you have to convert the centimeter into meter because diopter is the reciprocal of focal length in meters. So that's only case we'll convert the focal length in meters when you want to calculate the power. Otherwise, we'll just do it like this, 10. So it's 2, it's 1 minus 2, it's minus 1 by 10 and you got F to be minus 10 centimeter, which is correct because for a concave mirror, you all know the focal length is to the left. Anything to the left have to be negative. The focal length is negative. The radius of curvature is negative because it's all to the left of the pole. So you understood this. Let's go to next question. So then, I'm going to do the next sum. It's absolute clarity now. So let's go to example 21. A microscope is focused on the coin lying at the bottom of the beaker. Take a beaker. Make a coin lie at the bottom of the beaker. The microscope is focused on this. Directly horizontal. Not tilting and looking at it like this and all. Don't confuse yourself. Okay, just horizontally. Now you are raising the microscope. Screw you're just raising the height of the microscope by 1 centimeter. But the question is, it's an empty beaker initially. Now you have to fill it with water so that this coin is going to appear to be raised to the level of the microscope, which means you place the coin here. This will go like this. There will be normal at the point of incidence, and it's going to bend away from the normal, and so it's going to come from a point above, and correctly it will appear to be raised, and this microscope will be able to catch that image, which is a raised image, correct? So then therefore they are saying that it has to be in the level. This image has to be the level of the microscope. That's the question. So then what is the question again? The microscope is now raised by 1 centimeter. To what depth should the water be poured into the beaker so that the coin is again in focus? The refractive index of water has been given to be 4/3. Okay, you know this is, they are talking about shift. I just taught you this is shift formula. Shift is equal to T into 1 minus 1 by mu, where T is the entire depth of the water, which you don't know. How much depth, height, water is to be filled, you don't know. So write H into 1 minus 1 by mu, which is 4/3, which is 1 by 4/3, which is 3/4. And shift itself is 1 centimeter. Let's keep everything in centimeter only and do it. So 1 is equal to H into LCM at the 4 minus 3/4. 1 is equal to H into 1/4. So H is equal to 4 centimeter. Therefore, you have to fill up water till 4 centimeter so that the second position of the microscope can still catch the object's position. Are you clear? So let's go to next question. The next question is the 22nd example, wherein you have the bottom of the container is a 4 centimeter thickness glass slab. So you draw a container in which there is a glass slab of thickness 4 centimeter, which means this thickness is 4 centimeter, which means according to us the depth of that glass slab itself is 4 centimeter. That refractive index you know is 1.5. The container consists of two immiscible liquid A, which is occupying a depth of 6 centimeter, and B, which is occupying distance of depth of 8 centimeter B. They've already given the refractive index of A and B. This is refractive index is 1.4. This refractive index is 1.3. Let's call it as mu1, mu2, mu3. Let's call this as T1, this is T2, and then T3. You know, the question is, what is the apparent position of the scratch at the outer of the bottom? At the bottom outer surface of the beaker, you have a scratch that is going to be viewed through the container by the side. It's going to be raised. Okay, what is the apparent position of the scratch surface of the bottom when viewed through the container? So all I know is to calculate shift. Okay, you know there's a T1 into 1 minus 1 by mu 1 plus T2 into 1 minus 1 by mu 2 plus T3 into 1 minus 1 by mu 3 will be the shift due to all the three. So you know T1 is 4, 1 minus 1 by 1.5, okay, 1.5 plus T2 6, 1 minus 1 by 1.4 plus T3 depth 8, 1 minus 1 by 1.3. You could do this calculation. Do this calculation, you will end up getting an answer of 4.89. And that will be actually what we have done. Okay, so the total apparent shift in the position of the image due to whatever we have calculated is a shift. Correct? What will be the total depth? Therefore, can you see he is not completed. Aurora has not done well. 6 plus 8? 14. 14 plus 4? 18. So 18 minus 4.89 will be the apparent depth, because what we calculated is from the bottom, what is the shift? So you want the apparent depth, you should subtract, but he has not done that, no? He has only written only 4.89. Actually, what he is finding is the total shift. To find apparent depth, the total depth has to be subtracted by the total shift. That's when you get the apparent depth, but that he has not answered. But however, let's get to know both so that we are clear with our answer. Let's go to next question. The next question is the 23rd example. Example 23rd. Okay, a transparent cube of side. Okay, let's draw a cube. Tuck, 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 tuck. Cube. With this edge being 15 centimeter. One side itself is 15 centimeter. Every side therefore is 15 centimeter. Okay, contains a small air bubble inside. So it's got an air bubble inside, somewhere inside. Okay, not on the surface. Okay, its apparent depth when viewed from one face ஒரு ஃபேஸ்லேருந்து பார்க்கும்போது apparent depth is 6 cm. It's apparent, not real. இன்னொரு ஃபேஸ்லேருந்து பார்க்கும்போது apparent depth is given to be 4 cm. This is also again apparent only. So what is the real depth? You should consider this side the real depth is x. Without forgetting, this side is x and this side will be 15 minus x. If it is correct, that's correct. First one is x, next one is 15 minus x. And you know that, what is the refractive, this is a glass slab. What is the refractive index of glass slab? Water only 4 by 3. Glass slab is 3 by 2. Glass is always 3 by 2, 1.5. So 3 by 2 is equal to real depth. Let's do it on the left side. What is the real depth? Real depth is 15 minus x. What is apparent depth? 4. Let's do it for the right side. What is the 3 by 2 is equal to what is real depth? X. By apparent depth is 6. What is given is apparent depth? No. So then therefore, just cross multiply. This will become 3. X will become 9. Let's do it here. This is 2, 6, 15 minus x. So x is equal to 15 minus 6. Again you're getting 9. Both the places you're getting 9. So you know that this side the actual depth is 9 and that side 15 minus 9. What is 15 minus 9? 15 minus 9, 6. Therefore this side is 6. So from one side the real depth is 9. From the other side the real depth is 6. When the real depth is 6, the apparent depth is 4. When the real depth is 9, the apparent depth is 6. Are you clear? So that's what is this sum. So find, but the question here is find the refractive index of the cube. The question is not what I am doing. I am finding the real depth. Okay, but I use the refractive index. Don't use the refractive index because they have not given refractive index. They're asking you to find the refractive index. In that case, you put mu and mu. And then equate both. Just don't calculate like this. Just equate both. Right here 6, right here 4. And both the mu has got to be the same, right? So then equate both. 15 minus x by 4 is equal to x by 6. This will be 2 and 3. So 15 3s are 45. Minus 3x is equal to 2x. 5x is equal to 45. And therefore x is equal to 9. Take that and substitute in this formula. So then mu is equal to 9 by 6 or a 3 by 2. The question is to find the refractive index. I blindly substitute the refractive index and found the real depth. Don't do that. From left side and right side, write mu as mu only and write this formula. Equate both the mu's, you get the x. Substitute in one of the equations, you'll be able to get the refractive index. Are you clear? So let's go to example 24. Example 24, a cylindrical vessel of diameter 12 centimeter. A cylindrical vessel of diameter means, this is going to be a circular in shape, and so the diameter itself is 12 centimeter, which means radius will be 6 centimeter, and contains 800 pi centimeter cube. 800 pi centimeter cube, the entire volume of water has been given. A cylindrical glass piece of diameter 8 centimeter. Now we are going to place a glass piece here. Glass piece here. A cylindrical glass piece, so it has to be cylindrical in shape. Of diameter 8 centimeter, so radius will be 4 centimeter at height of 8 centimeter. So this height is given to be 8 centimeter. If the bottom of the vessel under the glass piece is seen by the paraxial rays, locate the image. The axial and paraxial. I'll just tell you the simple difference between the word axial and paraxial. Anything which is near the axis. The ray which is coming near the axis is called axial, which is coming far away from the axis will be paraxial. So let's see what he's trying to say, and that shouldn't be a deciding factor. We'll just do the sum. What is apparent position? Okay, so what am I saying? What am I reading? If the bottom of the vessel under the glass piece is seen through paraxial rays, locate the image. What image? The index of the refraction of glass is 1.50, which means refractive index. Index of the refraction means refractive index is 1.50 and that of what is 1.33. What the hell is this question? Let me first understand. Sorry guys, I will just make one small correction as to what are paraxial rays. Paraxial rays are those which makes a small angle with the axis, which means if it's like this, if it's far away, it will obviously make a larger angle. So which means they're talking about a line which are closer to the axis and not far away from the axis. Okay, so then I said something contrary to it in the beginning. Just make a note of it. We'll come to that later, however, we'll explain in the class. So in the paraxial, meaning whatever it is, we just leave it like that for now. Okay, now look at this. You're going to see the bottom of this container from outside. So there will be an apparent shift. Correct? The apparent shift from shift of the bottom, there will be an apparent shift due to this glass and due to the water above it. Now I understood why they are saying paraxial. Now I understood. Because paraxial means it has to be closer to the axis. Only when you look at closer to the axis, this glass will be there. This will be there. If you look away from the axis, you will get to see this will not even impact it. The kutti glass will not even have an impact if you look at it through paraxial rays. That is why, if you look at it from the rays which are away from the paraxial. So paraxial rays are those which are closer to the axis, and only when you look at it through paraxial rays will the effect be visible. So now I made a mistake initially. What is paraxial? So important to know what is paraxial. Is a line which is coming closer to the axis. When you look at close to the axis, this bottom glass will have an impact on it. Correct? So then we are looking at it through paraxial rays. Now we are very clear what is paraxial, closer to the axis. I'm sorry about what I said. I hope you are all clear. So now they have given the total volume of the water. You can find the volume of this glass. What is the volume of the cylinder? Pi r square h. Pi, let it be pi. R square will be 16. Into height is 8. 8 6 are 48, 8 1 is 8, 128 pi centimeter cube will be the volume of this glass slab. ஒரு தண்ணிக்குள்ள இவ்வளோ பெரிய glass போட்டா water will rise. So you have to find the raised water level. Okay, so then subtract this volume from this volume. So 800 pi centimeter cube minus 128 pi centimeter cube when subtracted will give you, we have to add, you have to add so that you get the total volume. It's going to increase the volume, right? Why am I subtracting? I don't want the difference in volume. I want the total volume. So the total volume itself is 928 pi centimeter cube. Once you know the total volume, you can find the total height, which will be the final height, because it would have risen, na? So you can find the total height. How to find the total height? The total height is volume by area, because volume is height into area. So height is equal to volume by area. 928 pi by area is 800 is the surface just the top area, which is pi r square. Shouldn't we be taking only the area of the bottom container, or should we take the area of the whole surface? You want the whole height, you should be taking the area of the whole surface. Okay, so then because the water level would have raised on the whole, and therefore 6 centimeters is what you should divide it by pi into r square, so that pi and pi gets cancelled. You divide it, you get the height. Once you get the height, it will be 25.78 centimeter. Thus you get the height, which is the final height. So to get the final height, once you drop something, the volume will only get added. With the added volume only, you can find the final height. So you find the final height. Now you know what is the level of the glass? 8 centimeter. So in this 8 centimeter is the glass. And subtracted, you get the height of the water level above it. So 25.78 minus 8 centimeter will give me 17.78 centimeter. That will be the height of the water above the glass. So redraw it. இங்கே கிளாஸோட ஹைட் இந்த வெளியில் இருக்கிறத பற்றி எனக்கு கவலையே கிடையாது. வாட் ஐம் லுக்கிங் அட் இஸ் ஒன்லி டில் தி கிளாஸ்க்கும் அதுக்கு மேலே இருக்கிறதுக்கும் தான் எனக்கு இந்த இடம் வரைக்கும் கிளாஸ் இருக்கு. இப்போ இந்த 17.78 வந்து இஸ் த வாட்டர் லெவல் அபவ் தி glass. You understand? This is the water level above the glass, and this is where the glass is, and we are talking about paraxial rays, which only confines you to this region. Correct? So now you can use the shift, which is T1 into 1 minus 1 by mu 1 plus T2 into 1 minus 1 by mu 2. What is T1? Is the thickness of the glass slab. 8 into 1 minus glass slab's refractive index 1 plus T2 is thickness of the water 7.78, depth of the water 1 minus 1 by 1.33, right? So you just substitute this and find the final answer. You will get the answer to be 7.1 centimeter. The total answer will be 7.1, which will give you the total shift. That will give you the total shift from the bottom. But that will not be, as I told you before, that will not be the apparent depth. If you want apparent depth, the question doesn't talk about apparent depth. They are only asking about what is the shift from the bottom. But if they ask you, you have to add this and subtract it from this. The total depth minus the shift will give you the apparent depth. If they ask you apparent depth, that they are not asking for the apparent depth. They are only asking for how much is shifted from the bottom. Are you clear? Beautiful. So going to the next concept now, we are going to talk about total internal reflection phenomenon. Total internal reflection phenomenon. Okay, what is total internal reflection? Let's do the theory first. Quickly, I'll do the theory. The advantage of learning from this video, it's called theory, numerical. Unlike the previous videos where I would have done completely continuously theory and dealt with numerical, this is even more beautiful. It's going to help every child. So this is what I'm doing. So you have this is a denser medium. This is a rarer medium. At the bottom of the denser medium, you have a mark. You have some mark here. Okay, so or a coin. This is denser medium, which is like glass, other air. So the light ray will come from this, and you have to do a normal at the point of incidence, and it will bend away from the normal. Okay, adhe coin length ray inga poi vidhu. I'm increasing the angle of incidence. This is my normal. Increasing the angle of incidence. It will bend more away from the normal. So if this is I1, this will be R1. This will be I2. Konja increased. R2 is also increasing. So now I'm going to increase the incident rate to such a wide extent that I do the normal. When the refraction is happening from one medium to another medium, so refraction. But the refracted ray will graze through the separation between the two medium. I'm sure you saw the video. It will graze through the keyword grazes through the separation between the two medium, which means the angle of refraction becomes 90. At this instance, the angle of incidence, you should call it as critical angle, beyond which when you increase the angle of incidence, it will get reflected back into the same medium. This phenomenon is known as total internal reflection phenomenon. Did you learn this? Yes. So what is total internal reflection phenomenon? Main condition. What is the main condition? It has to enter from denser medium to rarer medium. As you keep on increasing the angle of incidence, the angle of refraction keeps on increasing. At one particular angle of incidence, the refracted ray grazes through the separation between the two medium, beyond which when you increase the angle of incidence, it will get totally internally reflected into the same medium. This phenomenon is known as total internal reflection. And write it. It is entering from denser to rarer. So I'll write 1 by mu is equal to sin I by sin R, IC. I is IC and sin R is sin 90. Cancel it. Therefore, you get a beautiful formula. Sin IC is equal to 1 by mu, IC is equal to sine inverse of 1 by mu. If you know the refractive index, you can calculate the critical angle, beyond which it will get totally internally reflected into the same medium. Are you clear? So that completes this. So I'm going to tell you, you have to know about mirage. So for the first application of applications of total internal reflection. The first application is a mirage. Okay, there are many applications. I'll go one by one. மிராஜுங்கிறது என்னது அப்படின்னாக்கா, நீ ஹாட் சம்மர் டேயில் நீ காரில் போனேன்னு வச்சுக்கோயேன், லாங் டிஸ்டன்ஸில் பார்த்தீங்கன்னா தண்ணி மாதிரி இருக்கும். சின்ன குழந்தையில போகும்போது அங்கே போய் தண்ணி மாதிரி, நீ போக போக அந்த தண்ணி மாதிரி இருக்கிறது போயிட்டே இருக்கும். பார்த்துருக்கியா? ஒரு பெரிய ட்ரீ இருக்கு, இங்கே தான் நீ நிற்கிற. இது லேண்ட். ஹாட் சம்மர் டே the land get heated up very fast. Land is very hot. So above the air above the land will be hot இருக்கும்போது less denser. It will be hotல வந்து less denser and high above will be more denser. Okay, so when a light ray is coming from a tall tree into this man's eye, okay, it has to travel like this, right? கொஞ்சம் கோணல தான வருது. So when it comes, it is entering from a more denser medium into a less denser medium, which means they have varying refractive index, correct? So then even though it's just air, இது எல்லாமே ஃபுல்லாக ஏர்லேயே வேரியஸ் டென்சிட்டி இருக்கும்போது it will look at it as different medium. even though it's fully air. So the light ray is constantly, when it's coming from denser to rarer, it will move away from the normal. So when it enters his eyes, it's entering like this. Because it's constantly bending away from the normal, it is appearing to come from a point, it is appearing to come from a point below. So what he gets to see, he gets the object in the image formed in the same position on the retina, which means I am seeing you, un thala inga irukku, kaal kizha irukku. Inverted image, un kaal mele irukku, un thala kizha irukku. Rendu ore edathila vandha eppadi irukum? Will I be able to see you? I'll see some blurry image. That's what is called optical illusion, called a mirage. Mirage is an optical illusion. Optical illusion. How to explain? On a hot summer day, the land gets heated up very fast, and the air above the land is less denser. Hot means less denser, and the higher up will be more denser. So light from a tall tree, as it falls in the man's eyes, traveling from a more denser medium into less denser medium, and therefore total internal reflection phenomenon can occur. No, condition is more denser to less denser. Can understand? And it's constantly bending away from the normal, and due to total internal reflection, it is appearing to come from a point below the ground, and so then you get to see the inverted image and the object in the formed in the image, and don't say inverted object and the object are formed at the same position on the retina, so you get a blurry image, and that is known as optical illusion. Are you clear? So this applies to this is the definition and explanation you have to give when it comes to optical illusion. So as the angle of incidence becomes greater and greater, the critical angle will be reached, and beyond the critical angle, total internal reflection starts occurring, and the ray is getting reflected back into the same medium, can you see, and falls on the man's eyes, and these rays are appearing to come from a point below, and so then the observer's eyes, the rays reach the observer's eyes, and he sees the inverted image of the object as if formed in the pond of water, as if it's formed in the pond of water la irukra mari or illusion kedikudhu. The inverted image of the object, he sees it as if it is formed in the pond of water, and this is the explanation you have to give when you're writing about a mirage and an example. Are you clear? The next example that I could give you is periscope and kaleidoscope. Periscope and kaleidoscope. These are the next application. Okay, if you've seen this சின்ன குழந்தை இருக்கச்சு ஒரு டியூப் மாதிரி இருக்கும், அந்த விளையாடிருக்க திருவிழாக்கெல்லாம் போனால் ஒரு டியூப் மாதிரி எங்கள் ஊர்லலாம் கொடுப்பாங்க, கிராமத்துலாம் கொடுப்பாங்க. அந்த பெரிய டியூப்குள்ளே கடைசியில் பிட்ஸ் ஆஃப் பேப்பர் கிளாஸஸ் இருக்கும். அதில் வந்து சினிமா சிவாஜி படம், எம்ஜிஆர் படம்லாம் நிறைய தெரியும், நான் மல்டிபிள் தெரியும், டில்டாக தெரியும், இப்படி எம்ஜிஆர் அப்படி எம்ஜிஆர் அந்த மாதிரி. தட்ஸ் கால்ட் kaleidoscope, and this is periscope, which is used in submarines. In submarines you will have something like this. The submarines will be under the sea, so here there will be a mirror, and here there will be a mirror. So idu velila irukum, the sea idella full sea. See velile enna nadakudunu theriyunilla, inge inda vara ray inga poi ittai inga normal vara, just do a normal here. This should be greater than the critical angle, so that it will get totally internally reflected. Correct? Now do a normal here. This is getting totally internally reflected, and here you do another normal. You do another normal here. This should be again greater than the critical angle. So again it will get totally internally reflected, and will fall in the submarine la irukra ullu irukravனுக்கு வெளியில என்ன நடக்குதுங்கிறது தெரியும். கப்பல் வருதா போறதா ஷோரிங் எல்லாமே he'll be able to see. Are you clear? This is called periscope. So there are two applications, kaleidoscope and periscope, okay, where the total internal reflection phenomenon is applied. Are you clear? So now I'm going to tell you how a prism, kutti prism glasses, is able to tilt images. I told you about a kaleidoscope where there is many kutti glass prisms are added there. And so then let's see, or prism appdi irukku. It's a right angle prism. This is 90 degree, and you know this is 45 degree. A ray which is coming and falling on this. There's an object AB which is going to fall on this face. You have to know that there will be a normal here and normal here, which will be normal to this face, and this angle here will be greater than the critical angle, and greater than the critical angle it will get totally internally reflected like this. A ray coming along the normal will come out like this, going along the normal will go straight. So you get a tilted image where the A will be here and B will be here. It's 90 degree tilted. So you're able to tilt the image like this. And similarly, when you have a surface like this, they've drawn it like this, they're calling it as Q, P and R. They're drawing an image which is object which is AB. Along the normal straight up idum. But here there will be a normal, so this is greater than critical angle and this again greater than the critical angle. You know, it is going to get totally internal reflected. This is going to come here, this is going to come here. Here again you will have a normal. You have to draw a normal. If it is greater than critical angle, what will happen? This will come out. You don't have to do all that. You can just leave it like this. And can you see that the A goes here and A goes here and A comes down. The B goes here, B goes here and B comes up. It's 180 degree tilted. Can you see it's become 180 degree tilted. There's one more example that I want to give you. Is this. If you draw it like this, draw it like this, draw it like this. And this is 45 degree and 45 degree. Therefore this has to be 90 degree. It's a 90 degree. So in this you draw a AB. You know, it's going and falling not along the normal, it's going like this. And you know that it will bend towards a normal. If you have a normal here, say I'm going to do normal in blue color, normal to this face, normal to this face, it's entering from rarer to denser, so it has got to bend towards a normal. So bend towards a normal, sorry, not, I'm drawing along normal, bend towards a normal, and so it's bend towards a normal. It'll go like this, come out like this, come out like this, complete the diagram like this. So you will have an AB which will become a BA. Let's write it as B dash A dash. Image to be B dash A dash. Image to be B dash A dash. Just image itself is B dash A dash. So you know here again it's 180 degree tilted. So this is how you can tilt an object using a prism, and this is how kaleidoscope works on the basis of this. So then you understand how to invert objects. Invert an image by using total internal reflection phenomenon. Again, this is the next application. The other application is optical fiber. Optical fiber. Very, very important application. There is no paper without this optical fiber. Optical fiber நீ வந்து பீச்சில் விளையாடும் போது ஒரு சின்ன குழந்தைங்களாம் ஒரு 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 பிரைட்டாக ஒன்று இருட்டில் கூட பளபளன்னு தெரியும் ஒரு பொம்மை ஒன்று வாங்கும். கொரோனா மாதிரி இருக்கும் அந்த பொம்மை. கொரோனா மாதிரி இருக்கும் அந்த பொம்மை. அதை வச்சு அமுக்கலாம் ஒரு பிரைட் கலரில் இருக்கும், தெரியுதுல்ல? அது வந்து அப்படி கொரோனா மாதிரியே இருக்கும், இப்படி இருக்கும். அந்த அதை வச்சு எப்படி கூட விளையாடுறதுக்கு ஒரு லாங் பைப் மாதிரி கலராக இருப்பாங்க, அப்படியே ஆட்டுவாங்க பீச்சில். சின்ன குழந்தைங்க வந்து இருட்டில் கூட பளபளன்னு தெரியும். அது பார்த்துருக்கே இல்லையா? வெளியிலேயே போனது இல்லையா? வீட்டை விட்டு உனக்கு பார்த்துருக்கல? ஸோ தட் இஸ் கால்ட் ஆப்டிக்கல் ஃபைபர். பீச்சுக்கு போ காரில் போ, எதுவுமே பண்ணாமல் வீட்லேயே உட்காந்துருந்தா என்ன ஆப்டிக்கல் ஃபைபர். ஸோ இந்த ஆப்டிக்கல் ஃபைபருங்கிறது இருட்டில் கூட பளிச்சுன்னு தெரியும். that is used in telecommunication. underground wiring பண்ணுறாங்களே டெலிகம்யூனிகேஷன், நீ கூட கேட்டேன். that's optical fiber. ஆப்டிக்கல் ஃபைபர் வந்து நம்ம எனக்கு வயிற்று வலின்னு டாக்டர்கிட்ட போனால் வயிற்றுக்குள்ளே அல்சர் இருக்கான்னு பார்க்குறதுக்கு என்ன பண்ணுவாங்கன்னா வாய் வழியாக தொண்டை வழியாக அப்படியே விடுவாங்க ஒரு டியூப்பை. அது நுனியில் ஒரு பல்பு இருக்கும். ஓகே, அந்த பல்பில் ஒரு கேமரா இருக்கும். அந்த கேமரா வில் கேப்சர் வாட் இஸ் ஹேப்பனிங். அப்படியே அந்த டியூப் உள்ளே விடுவாங்க. வெறும் வயிற்றில் வர சொல்லுவாங்க, காற்றால சாப்பிடக்கூடாது, ஏன்னா வாந்தி பண்ணிவிடுவோம்ல. உள்ளுக்குள்ளே விட்டால் யூல் பியூக். ஸோ தென் தெல் எல்லாம் காற்றுலேயே எல்லாமே கிளியர் ஆகிடும். தெல் கிவ் அ மெடிசன் ஸோ தட் அவர் ஸ்டொமக் இஸ் கிளியர். தெல் புட் அ டியூப் த்ரூ த த்ரோட் அண்ட் இட் வில் கோ இன்சைட் கிடுக்குன்னு இட் வில் கோ. பயங்கரமாக இருக்கும். பட் எனிவே நான் எல்லாமே பண்ணியிருக்கேன். என் வயசானவன் எல்லாரும் பண்ணியிருப்பான். ஸோ தட் இஸ் கால்ட் எண்டோஸ்கோபி. எண்டோஸ்கோபி எடுத்தால் வயிற்றில் என்ன இருக்குது எல்லாமே வெளியே வந்துடும், எல்லாமே தெரிஞ்சிடும். அல்சர் இருக்கா, கேன்சர் இருக்கா. ஸோ தட்ஸ் வாட் எண்டோஸ்கோபி. இன்டெஸ்டின் வழியாக உள்ளே போகாது. ஸோ அந்த எண்டோஸ்கோபிக் விடுற டியூப் இஸ் மேட் ஆஃப் ஆப்டிக்கல் ஃபைபர். அது எப்படி இருக்குது? ஆக்சுவலாக அது ஒரு ரொம்ப தின்ன டியூப். இவ்வளோ பெருசாக வரைய முடியும்? அவ்வளோ பெரிய டியூப் கிடையாது. அது ஒரு தின் டியூப், வயிற்று தொண்டைக்குள்ளே போகணும். பட் however when I'm drawing big to show you what it consists of. An optical fiber consists of axis, just an axis. This is inner core and an outer cladding. It consists of an inner core and an outer cladding. The core is a denser medium and a cladding is a rarer medium, because you know for total internal reflection to occur, light has to travel from a denser to a rarer medium. So this is the axis. Okay, so supposing this is my stomach, and let's consider that the doctors have given me some medicine. There's nothing in my stomach, only air is there. Because I should not puke. So they gave me some medicine on the previous day, everything came out, my stomach is clean, there's nothing in it. So that the ray from air is going to fall on the axis. இந்த ஆக்சிஸில் தான் ஒரு கேமரா இருக்கும். த கேமரா வில் பி ஹியர். So this is my angle of incidence, which the incident ray from my stomach is making with the camera. Now this is entering from air into, can you tell me, it's entering from air into core, which is a more denser medium, so it has to bend towards the normal. So this is your R. But here I have to do a normal, and it is this place that the total internal reflection has to occur. So here is where it's entering from a denser medium into a rarer medium. So if this angle is greater than the critical angle, the total internal reflection will occur, and what I get to see here, appade reflect ஆகி எனக்கு கம்ப்யூட்டரில் கரெக்டாக ப்ரொஜெக்ட் ஆகிடும். This is what the doctors do. Are you clear? So this is called endoscopy. And the application, optical fiber is what is used in endoscopy. This is very important for you to understand where is the core, where is the cladding, where is the total internal reflection. The total internal reflection is occurring here, not here. This is from my ulcer to the axis to the core, and from core to cladding is where my total internal reflection. So there are many stages of working. There are many stages in which you have to understand. Okay, let's go in reverse. Here, let's go to this part, the last part, where total internal reflection is occurring. You guys know that sin IC is equal to 1 by mu. What is this mu? Mu of core with regard to cladding. Because the IC occurs only at this purple area, where the layer separating is only between core and cladding. So the mu has to be core with regard to cladding. And you know the sin IC therefore is 1 by mu of core by mu of cladding. So the mu of cladding will go up. If you do this, you can find what is IC. Take the sign to the other side. This will be some number, and so then you will get a critical angle. This critical angle, and you know this has to be greater than the critical angle. But for now, let me assume that this is just critical angle itself. Let's assume that this is IC. It has to be greater than IC theriyum. Let's take this triangle. You have an R plus 90 plus IC, but IC is greater than IC, but we'll assuming it as IC and writing it as 180. Taking the 90 that side, R plus IC is equal to 90. Therefore, R is equal to 90 minus IC. You know IC has to be greater than IC. So this has to be greater number. This will be R maximum that you get, because this has to be greater. This can be 30 degree and above. Say it can be 60. 30 this will be maximum, and after that it will be lesser and lesser and lesser. So what you get here is R maximum, because we have taken it as critical angle. However, you know it has to be greater than the critical angle. If it's greater, the value will become lesser. Correct? Because 90 minus some. So what you get is R maximum. This is the first step that you do. This is the second step that you do. And the third step come here. It is entering from air into core. Air into core. So the refractive index, it's entering from rarer to denser only. So mu is equal to sin I by sin R. This I is the angle of incidence, not I, where my stomach ulcer is falling. This R I can, if you know mu, which is mu of core with regard to air only, that will be given. You can cross multiply. Okay, you want to find sin I. Sin I therefore is mu of core into sin R. Stage by three stages with which you can find the angle at which the doctor should focus on my ulcer, so that it will get totally internally reflect. 3 stages in this, and you should understand all the 3 derivations. So let me go to next topic. So total internal reflection, I will say another example is diamond. Okay, when you take diamond, it will be cut like this. Diamond cutting ke specialist irupanga. It will be cut in such a way that any ray that comes like this and goes and falls here will fall in such a way that this is greater than the critical angle, so it will get totally internal reflected. Here again one normal will be there. This will be greater than glitter. Abdi reflect multiple reflection it will glitter. That's a whole purpose. And the refractive index of diamond is I think 2.4. Did you see that in the video?
Yes.
You saw it? The refractive index, diamond is the densest medium, and refractive index is 2.4 of diamond. Refractive index is 2.4, critical angle will be 24 degree. So, the critical angle is 24 degree means the angle of incidence can range from 24 degree to 90 degree. That gives you a wider range of angle of incidence for which it is getting totally internally reflected. The cutting பண்ணும்போது கரெக்டாக பண்ணணும். Diamond cutter is very, very special. So that is what makes it. This is the key point on this. And similarly, okay, I think even the rainbow formation is based on total internal reflection phenomenon. You know, that's not there for this year, but however, just get to know, you get this droplet here, sun lane the ray, it's coming and it will get dispersed because it's undergoing refraction. And you know, each ray, each color will travel with different speeds. Therefore, each color will get split up here. Here, correct? Because for every color, refractive index is inversely proportional to wavelength. So, according to each color's wavelength, the refractive index of the same medium can even vary. And so, it will bend differently. Speed will be different because refractive index is different, speed in the medium will be different. You know, mu is equal to C by lambda, C by B. So, we will differ. So, then therefore, each travels with a different speed and dispersion occurs. Now, at this point, if the angle is greater than the critical angle, total internal reflection phenomenon will occur and the light ray will emerge out and a big rainbow gets formed. So this place where total internal, that's again a phenomenon of total internal reflection. So that's enough. Okay, so next is I'll do some numerical using total internal reflection. Okay, so I'll go to I'll do some number. Okay, some number. Example 25. Example 25. Find the value of the critical angle for the material of refractive index root 3. Refractive index mu is equal to root 3. And you know sin IC is equal to 1 by mu. So IC is equal to sin inverse of 1 by mu, which is sin inverse of 1 by root 3. Where will sin angle 1 by root 3 will come? Sin 1 by root 3? We don't know. Because we know only triangles such as 1 to root 3. Correct? Where it's 60 degree and a 30 degree. You know sin 60 is root 3 by 2, sin 30 is 1 by 2, but you don't know where sin will be 1 by root 3. I wish it was, the question was about root 2. So you can write 1 by root 2 and therefore it will be 45 degree. If it was root 2 then you can find, otherwise you can't, you just have to write sin inverse and leave the question like that. Okay, that's about how to find the critical angle. So let's go to next question, is example 26. Calculate the speed of light in the medium with critical angle 30 degree. So there is a medium, that's this medium, in which the critical angle is 30 degree. When the critical angle is 30 degree, the angle of refraction will be 90 degree. And you can find what, you know that in this case total internal reflection, therefore mu is equal, IC is equal to sin inverse of 1 by mu. IC is equal to sin inverse of 1 by mu. They are asking you to determine the speed of light. You can find what is mu. So take it this way, sin IC is equal to 1 by mu. Yeah? So mu is equal to 1 by sin IC. What is IC? 30 degree. So mu is equal to 1 by sin 30. What is sin 30 degree? 1 by 2. So mu is equal to 2. You got the refractive index. You know mu is equal to, you know, speed of light in vacuum by speed of light in medium. The question is to find the speed of light in medium. So right here 2 is equal to 3 into 10 to the power 8 by V. Therefore V is equal to 3 into 10 to the power 8 by 2. So 1.5 into 10 to the power 8 meter per second. Are you clear? Super. So let's go to next question. Is the example 27. Example 27. Determine the direction in which the fish under the water sees the setting sun. So there is a தண்ணி இருக்கு, இதுக்கு அடியில் ஒரு fish இருக்கு. This fish has to see the sun setting.